photographs are really compelling because this is not somebody making believe something is there. You can actually see the skid marks. It actually looks as though an object is moving along that ice.
McMurdo Station occupies a rocky promontory on the southern shore of Ross Island in Antarctica. It acts as the primary logistics hub for United States research on the continent. Established by the U.S. government in 1956, the station can host up to 1,200 people during the austral summer. Scientists, pilots, engineers, and support staff come together under harsh conditions of cold, wind, and long hours of daylight to carry out work in fields ranging from glaciology to astrophysics. Between 1983 and 1997, a U.S. Navy flight engineer stationed at McMurdo logged hundreds of hours in the squadron known as the Antarctic Development Squadron. On routine missions, he flew personnel and supplies between McMurdo and scattered field camps. In clear weather, his crew often had views that stretched for miles across ice plateaus and jagged mountain ridges. During one flight through the Transantarctic Mountains, they encountered something that defied their training. High above the ice, a group of smooth metallic spheres appeared. Each object measured roughly 10 to 15 feet across and had a gleaming, silvery surface. They hovered at various heights, moving as a coordinated unit toward a particular rocky peak. As the spheres neared the summit, they paused briefly, then shot upward in unison before vanishing from sight. No change in wind or thermal currents explained their behavior. Onboard cameras captured only faint glints where shutter speeds were too slow. Radar screens showed blips that faded in a few seconds, leaving no solid track. Over the next several months, similar encounters took place. On each mission, the objects formed the same pattern. They hovered, converged on a single point, then dispersed instantly. Flight logs noted sudden magnetic spikes and brief power failures whenever the crew tried to record instrument data near the objects. Electronic compasses spun wildly, and radios hummed with static. Engineers rewired circuits and reset breakers, but anomalies recurred whenever the spheres appeared. One summer, a field scientist suffered a severe medical episode at a remote camp. Time was critical. A long-range flight would be the only way to save the researcher's life. The squadron approved a flight path that cut across a mapped no-fly zone, a vast expanse of ice known for hidden crevasses. As the plane descended toward the camp, it passed over a feature the crew had never seen on maps or satellite imagery. A massive circular opening in the ice, tilted downward at about a 30-degree angle. From above, the cavity resembled the mouth of a tunnel carved into the glacier. Its diameter stretched nearly 200 feet. Along its edge, walls of blue-tinged ice rose sharply, framing darkness within. As the aircraft came within a few hundred feet of the rim, onboard instruments went offline. The cockpit lights dimmed. Digital gauges froze, then reset. Compass needles spun without settling. Radios cut out. Mechanical systems remained functional, but all electric power flickered. The pilot climbed rapidly to clear the area. Once the plane was several thousand feet above the hole, power returned. Radios crackled back to life. Navigational instruments realigned. The crew completed the medical evacuation without further incident, then flew back to McMurdo. Upon landing, they were met by civilian-dressed officials who displayed credentials from a government office in Washington, D.C. These men escorted the crew into a private area and instructed them never to discuss the ice opening or the instrument failures. Orders included formal non-disclosure agreements and warnings of legal consequences for any breach. Despite the official silence, word of the event spread among station personnel. Maintenance logs contained vague references to unexplained power surges on aircraft systems. Meteorological reports noted sudden magnetic disturbances near the mapped coordinates of the hidden cavity. Geologists reviewing ice core records found anomalous layers in that region, zones of refrozen meltwater mixed with sediment, appearing out of sequence in depth profiles. But no public report ever mentioned an ice tunnel or related heat sources. Decades earlier, in 1947, Admiral Richard E. Byrd led a U.S. expedition to the South Pole region. During flights over the polar plateau, Byrd described seeing what he called a great fissure in the ice, hinting at a passage leading into a warmer, ice-free zone below. Official expedition documents emphasize mapping, meteorological observations, and equipment tests. They do not mention any subterranean entrance, yet personal journals and later interviews attributed to Byrd speak of magnetic anomalies and unexpected temperature readings near unnamed features. After his return, he underwent a confidential debriefing in Washington. He was, according to hearsay accounts, cautioned against speaking further about any underground opening. Skeptics argue that wind-driven erosion and solar melt can form large ice caves and tunnels along rock faces. They point to known ice arches on nearby islands, which collapse and reform each year. Instrument failures, they note, often occur in extreme cold when circuits encounter ice crystals or sudden temperature shifts. Solar flares can disrupt navigational equipment at high latitudes. In such an environment, pilots learn to expect compass errors and power glitches. Still, the combination of first-hand sightings, repeated magnetic spikes, and military-enforced secrecy has not been fully explained. McMurdo Station operates one of the most advanced scientific programs in Antarctica. Ice cores drilled near the pole reveal climate data stretching back hundreds of thousands of years. Deep-sea divers explore sub-ice marine ecosystems. Seismographs record tremors from thousands of miles away. Yet certain flight paths are now off-limits, and pilots receive briefings to avoid specific coordinates. Now, let's turn our attention to another mystery. Wilks Land sits on the eastern side of Antarctica, largely hidden beneath a thick ice sheet. Underneath that sheet, roughly 1,600 meters below the surface, lies a mass of rock far denser than the surrounding crust. This feature shows up as a strong gravity signal when measured from space. Scientists call it the Wilks Land gravity anomaly. Most people think Earth's gravity is the same everywhere. In reality, it varies slightly from place to place. Dense rock pulls harder on satellites than lighter rock. Mountains, dense mineral deposits, and deep trenches all leave small fingerprints in Earth's gravity field. To map these variations, researchers use satellites that can feel tiny changes in pull as they circle the globe. In March 2002, a pair of satellites lifted off from the Plesetsk Cosmodrome in Russia. They formed the GRACE mission, Gravity Recovery and Climate Experiment. Flying about 200 kilometers apart in a near-polar orbit, the satellites measure how the distance between them shifts. When the lead satellite passes over a region with stronger gravity, it pulls ahead and increases the gap. When it leaves that region, the gap shrinks. By tracking those shifts, scientists build a global gravity map. When GRACE data began to stream in, it revealed a ring-shaped gravity low over the ocean and several gravity highs on land. One of the most striking highs lay under Wilks Land. In a place where no mountain range or known dense rock should exist, GRACE showed a concentration of mass roughly 320 kilometers across. The strength of the signal suggested a plug of dense rock more than 100 kilometers thick. In 2006, geophysicist Ralph von Fries and his student Laramie Potts at Ohio State University published a paper on this finding. They combined GRACE gravity data with ice-penetrating radar and seismic surveys flown over Antarctica. Radar profiles revealed a roughly circular ridge on the bedrock surface, buried under ice. The ridge measures close to 500 kilometers in diameter and stands up to 300 meters above surrounding terrain. Seismic soundings showed a plug of dense mantle material beneath the ridge, extending at least 100 kilometers down into the crust. Von Friesen noted that, on the Moon, similar gravity highs appear at the centers of impact basins. He wrote, "If I saw this Mascon signal on the Moon, I'd expect to see a crater around it." On the Moon, large impacts send dense mantle rock upward, filling the basin and creating a mass excess known as a Mascon. The same process could explain the Wilks Land feature. A meteor or asteroid, perhaps 20 to 30 kilometers wide, could have struck Antarctica late in Earth's history. An impact of that size would have left a crater over 400 kilometers wide and driven up mantle rock into the crust. Further support comes from layers of molten rock in the area. Samples from offshore volcanic ridges north of Wilks Land show pulses of magma around 66 million years ago, at the end of the Cretaceous period. That date coincides with the mass extinction that wiped out the dinosaurs. Some researchers suggest the Wilks Land impact may have contributed to environmental crises at that time. The impact could have thrown dust and aerosols into the atmosphere, lowering temperatures and blocking sunlight. If true, it might join the Chicxulub impact in Mexico as a twin strike that shaped Earth's history. Not everyone agrees on the impact theory. Some geologists propose that the dense mass represents upwelling mantle rock, similar to mid-ocean ridge processes. In this view, hot mantle material slowly rose into the crust, pressing upward and forming a circular bulge. As magma cooled, it left behind a plug of dense igneous rock. Over millions of years, erosion and ice flow erased surface traces, leaving only the gravity signal. To test these ideas, scientists have examined the thickness of the Antarctic crust in that region. Using seismic waves, they found the crust beneath Wilks Land is thinner, around 35 kilometers, than the global average of 40 kilometers. Thinner crust fits both scenarios. Impact excavation could remove crust, or mantle upwelling could push it aside as new material rises. But the circular ridge and Mascon pattern match impact basins more closely than volcanic provinces. Drilling through 2 kilometers of ice to reach bedrock remains a challenge. The cold, remote location and logistical costs make direct sampling difficult. No Antarctic drilling project has yet targeted the Wilks Land structure. Without rock samples from the feature itself, researchers rely on remote sensing and comparison to known impact sites. Meteorite fragments, or shocked minerals, key proof of an impact, remain undiscovered. Beyond scientific interest, the anomaly raises other questions. Could a buried crater hold oil or gas deposits? Unlikely in Antarctica, where international treaties ban mineral exploitation. Could ancient rivers or lakes have formed in the crater long ago, trapping sediments and fossils? Possibly. Subglacial lakes already exist in East Antarctica. If any lay in the Wilks Land basin before ice covered it, they might contain records of past climates and microbial life. However, no sonar or radar survey has yet detected a lake in that exact spot. The Wilks Land gravity anomaly also fuels fringe theories. Some claim it marks the remnants of the lost city of Atlantis, or a hidden Nazi base. They point to Operation High Jump in 1946-47, when the U.S. Navy sent thousands of personnel, ships, and aircraft to Antarctica under Admiral Richard E. Byrd. Official documents state the mission's goals were training in polar conditions and establishing a research base. Conspiracy writers suggest High Jump secretly searched for an entrance to a hollow Earth or alien installations. They cite Byrd's own diary, which mentions unusual electromagnetic readings and unidentified flying objects. Yet mainstream historians find no credible evidence that high jump aimed to locate hidden structures. More sober theories link the anomaly to natural processes at the edge of the East Antarctic craton. The craton is a stable block of ancient rock dating back 3 billion years. Tectonic fractures and ancient rifts lie beneath the ice. In the past, these rifts hosted volcanic activity and may have formed large basins. As ice advanced and retreated, sediments filled those basins. Heat from Earth's interior melted some of the lower ice, creating subglacial lakes. Gravity measurements today pick up the combined effect of dense bedrock, sediment, and water. Looking ahead, scientists plan new surveys with more sensitive instruments. NASA's GRACE-FO follow-on mission, launched in 2018, continues gravity mapping. Ice-penetrating radar aboard aircraft provides higher-resolution views of the bed beneath. Seismic stations on the ice surface record distant earthquakes, helping map crustal thickness in detail. If funding and environmental approvals permit, a deep drilling project could reach the anomaly itself, bringing back core samples for chemical and structural analysis. Even without direct samples, models of ice flow may reveal the crater's shape. Ice moves predictably over uneven bedrock. By tracking surface elevation changes and radar profiles, researchers can infer valley shapes and ridgelines. If the anomaly includes a central peak, a typical feature of large impact craters, it may show up as a bump beneath the ice. Some early models hint at a gentle rise in the center of the gravity low, but data are not yet conclusive. Beyond Wilks Land, Antarctica holds other secrets far beneath its ice and snow. Each one offers a glimpse into hidden worlds, biological, geological, and even atmospheric, that challenge what we think we know about our planet. Blood falls. On the Taylor Glacier in the McMurdo Dry Valleys, bright red water flows from a crevasse in the ice. First noticed in 1911, this bloodfall looks like a wound in the glacier. In reality, iron-rich water seeps from a pocket of salt, saturated ancient seawater trapped under the ice. As the water meets the air, iron oxidizes and turns the stream crimson. Microbes living in the salty water derive energy by oxidizing iron, surviving in total darkness and cold. Bloodfalls shows life can thrive in places once thought uninhabitable. Lake Vostok. Beneath more than 4 kilometers of ice under Russia's Vostok Station lies one of the largest subglacial lakes on Earth. Isolated for millions of years, Lake Vostok has never seen sunlight. In 2012, Russian teams drilled into it and retrieved water and ice samples. Those samples revealed bacteria never seen elsewhere. Researchers study Lake Vostok to learn how life might survive on icy moons like Jupiter's Europa or Saturn's Enceladus. Its deep waters may contain oxygen trapped under pressure, creating a unique habitat for microbes. Moving rocks of the dry valleys. On several glacial flats, smooth stones leave long trails on dry mud as they shift position over time. Called moving rocks, or sailing stones, these pebbles glide silently, crossing plains without human or animal help. Scientists found that under rare conditions, thin ice, light winds, and sun-warmed ground, ice sheets form around stones and tilt them. When a gentle breeze pushes the ice, the stones coast along, carving tracks. Even so, the sight of isolated rocks scoring long lines across a frozen lake bed still surprises visitors. Subglacial rivers and lakes. Satellite altimetry and radar surveys have revealed over 400 subglacial lakes beneath Antarctica's ice sheet. These bodies of water link through hidden rivers, carving pathways over bedrock. In East Antarctica, melted water flows under pressure for hundreds of kilometers, emerging at ice shelf edges and affecting how quickly ice reaches the sea. Mapping these networks helps researchers predict how Antarctica's ice will respond to warming. It also suggests isolated pockets where life could exist away from surface extremes. Meteorite graveyards. Antarctica's cold desert collects meteorites that fall from space. As ice flows toward the coast, it pushes embedded meteorites against mountain ranges, concentrating them in blue ice areas. Scientists have recovered over 50,000 space rocks here, nearly 80% of known meteorites. Among them are fragments from Mars and the Moon, as well as rare carbonaceous chondrites carrying organic compounds. These finds help us understand the early solar system and the building blocks of life. Emperor penguin communication. Emperor penguins breed on sea ice in Antarctica's deep winter. They endure temperatures below -40 degrees Celsius and months of darkness. By standing in tight huddles, they share body heat. Each bird learns to recognize its mate's call amid thousands of squawking adults. In recent years, researchers using drone and acoustic surveys discovered that penguins also use low-frequency calls to signal weather changes. One study showed a unique deep boom that may warn of incoming storms, giving the colony time to tighten its huddle before a blizzard. The ozone hole and its effects. Each Antarctic spring, a vast hole opens in Earth's ozone layer above the continent. First noticed in the 1980s, this depletion results from human-made chemicals called CFCs. Ultraviolet light breaks CFC molecules apart, freeing chlorine atoms that destroy ozone. The ozone hole shifts weather patterns in the southern hemisphere, affecting wind and rainfall. After an international ban on CFCs, the ozone layer shows signs of recovery. Continued monitoring over the Antarctic sky remains critical to understanding global climate. Cosmic neutrino detection. Under the ice near the South Pole, scientists have built the Ice Cube Neutrino Observatory. They've drilled strings of light sensors more than 2 kilometers deep into the ice. When a neutrino, a tiny, nearly massless particle, interacts with the ice, it emits faint flashes of light. By capturing these flashes, IceCube tracks neutrinos from deep space. In 2018, it traced one high-energy neutrino back to a galaxy 3.7 billion light-years away, opening a new window on the universe. Antarctic blood falls. In addition to the Taylor Glacier site, other red-stained outflows appear where iron-rich water meets oxygen. Each presents a chance to study extremophile microbes. Some researchers target these flows for enzymes that remain active at sub-zero temperatures. Such enzymes may find use in industrial processes and biotechnology. Seismic mystery quakes. Seismometers on the ice record tremors too small for humans to feel. Some of these ice quakes occur when ice shelves crack or move. Others register as long-period events without a clear source. Researchers debate whether these signals come from subglacial lakes shifting, volcanic activity under the ice, or even distant storms. Pinpointing the causes could improve models of ice sheet dynamics and reveal active processes deep under the ice. Ancient fossil forests. In rocky areas now at the West Antarctic ice sheet's edge, fossilized tree stumps and leaves date to the Eocene epoch, 50 million years ago. At that time, Antarctica sat further north and supported forests. Finding these fossils helps scientists reconstruct past climates. It also shows how continental drift and greenhouse gas levels once combined to warm the planet enough to support temperate flora at high latitudes. Antarctic winds. The katabatic winds of Antarctica are gravity-driven blasts, flowing downhill from the high interior to the coast. In some valleys, speeds exceed 300 kilometers per hour. These cold, dense airstreams shape ice-forming patterns and scour the landscape. They also influence weather on neighboring continents by altering air circulation. Observing wind effects here improves our understanding of global jet streams and storm tracks. Remote research aircraft, unmanned aerial vehicles now survey hard-to-reach areas of Antarctica. Equipped with ice-penetrating radar, gravimeters, and magnetometers, these drones map bedrock topography, subglacial channels, and gravity anomalies in high detail. Early flights already revealed small lakes and caves that escaped satellite detection. As technology improves, UAVs promise more discoveries without risking human safety. So what are your thoughts on these mysteries? Let us know in the comments below, and subscribe to our channel for more content.